Hello and welcome to our senior design capstone project with California Pellet Mill or CPM Roskamp. With me, I have Ryan, Emma, Levi, Rachel, and myself, Okato. So CPM Roskamp is a leader in automated systems and process equipment, and they're interested in helping their industry customers improve their soybean oil processing by improving quality control methods in their flakers. The measuring process is crucial to obtaining the most soybean oil to their customers. So our objectives include developing continuous or frequent monitoring of the CPM flakers to detect out of specification parameters more often than the current sampling frequency of twice per shift. Another objective is to decrease human action by more than 50% when sampling soybean flakes by automating their current 15-minute process of manually measuring flake thickness accurately with less than 10% error compared to the current manual methods. And our last objective is to find or develop technology that will lead to a 20% reduction in oil loss in the soybean flaking process to implement in CPM's flakers.
So for our current state, we visited a site to collect flakes and measure their thickness to determine how in control the process is, which, as you can see here, process control limits are larger than the customer spec limits, which means that oil is being lost during production because of too thick of flakes. So capacitance sensors can measure the profile of the roller to determine the wear, which is seen on the left, and then the middle position sensors can measure the difference between the axes, and then the resultant flake thickness can be calculated.
So in order to validate the sensor that we chose, we mounted it to a steam dryer tube, which is similar to what the rollers that CPM Roskamp would be using. So the measurements were taken and graphed as the roller moved around to show the variation along its profile, which is that picture in the bottom right corner. And then we proved that the sensor can measure on a moving object that's similar to the rollers that it will be measuring in real life.
So then we did a benchtop test using a CMM machine to get specific known measurements of the distance between a sensor and a measurement, and then compare that to the voltage that's coming out of the sensor into our Arduino system. And then we use that to find a correlation and the sensitivity of our sensor. So based on the Arduino and sensor outputs, we can say that it can measure down to about 0.0005 inches when the sensor is close enough to the surface.
For our economic impact for our current customers, the percentage increase in profits based on the current gross margin on soybean oil and projected saving from installation of the measurement technology is 2.51%. And the qualitative impact on current customers is an increase in oil production while reducing overprocessing, and it reduces setup times in downstream processing. And specifically for CPM Roskamp, it increases CPM Roskamp's profit margin per flaker by 22%. Thank you, CPM Roskamp, for this opportunity.